Problem number 1. Which cloud contains 4 even numbers? So if you look at all the clouds on the paper, all the clouds only have 4 numbers in them. The first number is already a 3. So therefore, the numbers can't have all 4 as even because 3 is odd. And then if you look at B's cloud, the first number is 33, which is odd. So that can't be it either. So if you look at C, the first number is 3. So that can't have all 4 as even either. If you look at D, then the first number is 1. So then that can't have all 4 even numbers either. So that's not it. Then if you look at E, the numbers are 10, 2, 34, and 58. Therefore, all the numbers are even, and that is our answer. Problem number 2. How many hours are there in 10 quarters of an hour? 10 quarters is also 10 by 4. So if you simplify that, you get, or if you solve that and turn it into a mixed fraction, you get 2 2/4, which is also known as 2 1/2. And if you look at the answer choices, answer choice E says 2 1/2. Therefore, that is our answer. Problem number 3. A 3 by 3 by 3 cube is built from 1 by 1 by 1 cubes. Then some cubes are removed from front to back, from left to right, and from top to bottom as shown in the figure here. How many 1 by 1 by 1 cubes are left? So if you there's a total of 3 by 3 by 3 cubes, which is 27 cubes. And if you count how many cubes are removed, you'll see that 7 cubes are removed. And 27 minus 7 equals 20, and that is C. Problem number 4. 3 rings are linked as shown in the diagram. Which of the following diagrams also show the 3 links linked in the same way? So in the diagram, we have the gray link and the black ring are not linked together. And the gray is linked with the white and the white is linked with the black. So if you look at answer choice A, all 3 of the links are linked together, but they aren't supposed to be. So A is not our answer. Then if you look at answer choice B, we have the gray link is underneath everything else because it doesn't go on top of any of the other links. Therefore, it's just sitting there unlinked to anything. But it's supposed to be linked to the white. So therefore, B is not our answer either. For C, if we look closely, we see none of the links are linked with each other. So therefore, our answer cannot be C. If we look at D, then we see that it looks alright because the black and the gray aren't linked, and then the gray is linked with the white and white is linked with black. So that could be our answer. Now if you look at answer choice E, we see that the gray and black aren't linked, but then the gray and white aren't linked either because the gray is just completely underneath the white, which means it's not linked. Therefore, E can't be our answer either. Therefore, the answer has to be D. Problem number 5. Which of the following diagrams below cannot be drawn without lifting your pencil off the page or drawing along the same line twice? So if we draw A, you draw it like this. Then for B, you could just draw a normal square just like that. Then C is like this. D is like this. And then you'd have to retrace a line. So we can't do D, which means it could be our answer. We can do all these, so they're not. Then let's just check E to be safe. Let's just do it right here, I guess. So for E, we have this, or this, then you do it like, for E you'd go like this. Or you'd go down there and there. So therefore you could do this as well. And the only thing that we can't do is D, therefore that is our answer. Because we need to go like this, but we can't do it without retracing that. Now we're going on to number 6. 5 friends met, each of them gave a cupcake to each of the others. They then ate all the cupcakes they had been given. As a result, the total number of cupcakes they had decreased by half. How many cupcakes did the 5 friends have at the start? So each person, let's call this person 1, and then there's 2, 3, 4, and 5. So each person gave away 4 cupcakes. So if 5 people each gave away 4 cupcakes, then there'd be 20 cupcakes that people got. And it said that they ate all the cupcakes that they had been given. So 20 cupcakes were eaten, and that is half of the total number of cupcakes they had. So if 20 equals half of the total number of cupcakes, then the total number of cupcakes has to be 40. Therefore, our answer is D. Problem number 7. In a race, Lodar finished before Manfred, Victor after Jan, Manfred finished before Jan, and Eddie finished before Victor. Who finished last of these 5 runners? So if you draw this number line like thing, you have first, which would be whoever finished first, and last would be somewhere over there. Now first we have Lodar before Manfred, so we can put Lodar over there and Manfred somewhere there. Then it says Victor after Jan. We don't know where to put either of them in relation to them, so let's wait until later. Manfred finished before Jan. Now we can put Jan over here. And it says Victor finished after Jan, which means Victor is somewhere over there. Then it said Eddie finished before Victor. So Eddie can be anywhere from here to here, anywhere. Except we know Victor finished after Eddie. And if we look on this number line, we see that Victor finished last of those 5 runners. Therefore, our answer is A. Next, problem 8. These pages of the book Julia is reading are all numbered. The numbers used on the pages contain the digit 0 exactly 5 times and the digit 8 exactly 6 times. What is the number on the final page? So we have 0 through, or first let's start with 1. So we have 1 through 10. This has the 8 one time and the number 0 one time. Then in 2 through, or in 11 through 20, same thing. We have another 0, or another 8 and another 0. So therefore we have so far 2 zeros and 2 8s total. And if you keep going, it asks for 5 zeros and 6 8s. So if we keep going into the 40s, we have 41, which should be 41 through 50. This would be our 5th 8 here and our 5th 0 all the way here. This would be our second one. And then there's 5 zeros, but we want 6 8s. So now we keep listing 51, 52, 53, to 58, which would give us our 6th 8. So we have used 5 zeros and 6 8s. Therefore, our final number would be 58, and our answer is B. Now we are on problem number 9. A large square is divided into smaller squares. What fraction of the large square is colored gray? So this is what the figure looks like. And all these are gray. And along with this whole square. So if we divide each and every square into 9 pieces, like this, we divide it into 9 pieces like this, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 pieces that are colored. And we have a total of 36 little pieces. Now if you simplify that fraction, you get 4 over 9. And if you look at the answer choices, you see that that answer is D. Now problem 10. Andrew divided some apples into 6 equal piles. Boris divided the same number of apples into 5 equal piles. Boris noticed that each of his piles contained 2 more apples than each of Andrew's piles. How many apples does Andrew have? So let's put Andrew's piles over here and Boris's piles over here. So Andrew got 6 piles and they have the same amount of apples, so it's equal to Boris having 5 apples or 5 piles with 2 more apples in each pile. So if you solve this, you get 6x equals 5x plus 10, and x equals 10. And we want to know how many apples Andrew has total, which is 6 times 10 apples in each pile, and 6 piles total, so 6 times 10. And that is equal to 60. And the answer is A. Problem number 11. A different 4-digit number was written on each of the 3 pieces of paper. The pieces of paper are arranged so that 3 of the digits are covered as shown. The sum of the 3 4-digit numbers is 10126 or 10,126. Which are the covered digits? So you have 1, 2, 4, 3, 2, 1, blank 7, and blank blank 2, 6. And if you add everything up, it's equal to 1, 0, 1, 2, and 6. So then, if you want to separate all your digits, it makes it a lot easier to see which numbers lead to which digit total. Over here. So you have 3 plus 7 is 10, plus 6 is 16. 6 over there, 1 gets carried. 4 plus 1 is 5, plus 2 over here is 7. But we want to get something ending with a 2. So if we add a 5 over there, then you'll get 12, and a 1 gets carried over. 1 plus 2 is 3, plus 1 is 4. So you add another 7 to make it 11, and 1 gets carried over. 1 plus 1 is 2, 2 plus 2 is 4, and 4 plus a 6 over here makes that 10, and 1 gets carried over, which gets written here. So the numbers that we want are 5, 6, and 7 here, and the answer that has those 3 numbers is A. Problem number 12. In the diagram, PQ equals PR equals QS and angle QPR equals 20 degrees. What is the size of angle RQS? So we have this figure here. Q, P, R's over there, and then there's S over here. Then it says that this equals that. And this is 20 degrees. So if we notice here, we have an isosceles triangle. So this angle must equal to this angle. And the sum of all 3 angles of a triangle has to be 180 degrees. So 180 minus 20 equals 160. So each of these angles must be 80. And then over here you have an isosceles triangle over here. So if this is 20, then this also has to be 20 because these 2 sides are equal. So if you have 20 plus 20 over here, then you have 40. And the total of this whole triangle has to be 180. So you have 180 minus 40, which is equal to 140. However, we already have sum of this angle is 80. So 140 minus 80 is the remaining angle, which is 60. So right there is 60 degrees. And it's asked for RQS, which is that angle right there. So therefore, our answer is 60 degrees, which is also known as B. number 13. Which of the following 4x4 tiles cannot be formed by combining the two given pieces? So if you look at A, you can put the first piece like this. So the first piece can go like this, where this one, and this one are shaded. And the second piece, you can put in, I'll use a different color here. The second piece can go right here. So then you have that where this one, and this one are all shaded. And this forms figure A. Now, so therefore our answer cannot be A. Now let's move on to answer choice B. For answer B, we put the first piece like this. And it's shaded in here, here, and here. Then we put in the second piece, just like this. And we rotate it so it is shaded here, here, and here. And this makes answer choice B, therefore it is not our answer. And now we can do answer choice C, which this is the second piece would go right there, and it would go 1, 2 over here, and the third one would get shaded here. And then the first piece would go right there, so that it is like this, and then it is shaded here, here, and here. And this is exactly how figure C looks, so we can make it, and it is not our answer. And figure D, we can make it like this. And then we can put in the second figure right here, so that it looks like this. And this makes figure D. Therefore, the only figure left is figure E. And if you look at it, we are not able to make it, and therefore our answer is E. Problem number 14. Alan, Bella, Claire, Dora, and Eric met at a party and shook hands exactly once with everyone they already knew. Alan shook hands once, Bella twice, Claire 3 times, and Dora shook hands 4 times. How many times did Eric shake hands? So you have A, B, C, D, and E. A shook hands 1 time, B twice, C 3, D 4, and E we don't know yet. So let's say A and D shook hands. Then this one's done already. Let's say B and D shook hands and B and C shook hands. Then this one has all 2 done. This one needs 2 more because it's only shaking hands with B. So let's say it and D shakes hand and it and E shakes hand. Then we're done with C because it has 3 times that it shakes hand. Then if we look at D, it only has 3, so therefore has to shake hands 1 more time. Then if you look at it, E has shaken hands 2 times, and therefore our answer is B. Problem number 15. Jane is playing basketball. In a series of 20 shots, Jane scored 55% of the time. After 5 more shots, her scoring rate increased to 56%. How many of the last 5 shots did she score? So first you have scored 55% of 20. That is 11. So first she has scored 11 shots. So you have 11 out of 20. And then she has scored something out of 5. So you'd add 5 to the denominator and add x to the numerator. And that equals, let's say, y over 25. And y over 25 is supposed to be equal to 56%. So we have y over 25 equals 56 by 100. Then if you divide both sides, or like both the numerator and the denominator by 4, you get that that is equal to 14 over 25. So therefore, we know that y equals 14. Now we need to solve for x. So we have 11 plus x equals 14. Therefore, x has to be equal to 3. Then our answer is C. Problem number 16. Kathy folded a square sheet of paper exactly in half twice and then cut it in the middle twice, as shown in the diagram. How many of the pieces that she obtains are squares? So you have a square sheet of paper here. Then you fold it along this middle right here. Then when you fold it, you get one rectangle, and behind it, it's like folded again. And then you fold it again twice, or no, you fold it again once, and then you get something like this, where it's a nice square. Then when you cut it along here, if you want, you could try to visualize this, or you could get a paper and like actually rip it out with your scratch paper. But when you do this, you get 4 papers that are like a nice small square once you actually cut it out and then unfold all the papers that you get. Because if you look over here, the papers here are still connected by some edges because you're not cutting out all the edges out as well, you're just cutting among the middle. So some of the papers will unfold into rectangles like this. But we don't care about the rectangles, so we can ignore them. Then we also get one square that looks like this, with 4 little squares inside it when we unfold it. So then you get 4 small squares and 1 big square, and then we get 4 plus 1 equals 5 total squares. If you want, you can try this out with like some scratch paper that's squared. So if you get square scratch paper, or you make a scratch paper into square, you can try it out. But you get 5, which is C. Problem number 17. Michael has dogs, cows, cats, and kangaroos as pets. He tells Helen that he has 24 pets in total and that 1/8 of them are dogs, 3/4 are not cows, and 2/3 are not cats. How many kangaroos does he have? So we have 1/8 that are dogs. So 1 by 8 times 24 equals 3 dogs. We'll call it a D. 3 by 4 are not cows. That means 1 by 4 are. So we have 1 by 4 times 24 equals 6 cows, CO for short. Then if 2/3 are not cats, then 1/3 is. So 1 by 3 times 24 equals 8 cats, with an CA. So then you have 3 plus 6 is 9, plus 8 is 17 that are not kangaroos. So then you have a total of 24. Then you subtract the 17 that are not kangaroos, and therefore you get 17 that are kangaroos. There. So then the answer of 7, you get 17 not kangaroos, so 7 kangaroos. Then the answer of 7 is D. Next, problem 18. Some identical rectangles are drawn on the floor. A triangle with base 10 centimeters and height 6 centimeters is drawn over them as shown, and the region inside the rectangles and outside the triangle is shaded. What is the area of the shaded region? So if you look at the figure, you see 5 lengths is equal to a total of 10 centimeters, because you have 5 rectangles that are lined up against the 10 centimeter mark. Then you have 4 widths or 4 heights that come up to 6 centimeters. So you have each length is 2 centimeters and each width is 3 halves if you simplify 6 over 4. So then they ask for how much is shaded, which means how much is not covered up by the triangle. So area of a triangle is 1/2 times length, or times base times height, or length times width. So we have 1/2 times 10 times 6, which is equal to 30. The area of everything, if you count, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 rectangles. So we have 14 times the area of each rectangle, which is length times width, which is 2 times 3/2, and that equals 42. So then you want what is outside of the triangle, but inside like the total area. So you have 42 minus 30 equals 12, that is outside and shaded. And therefore the answer of 12 is B. Problem number 19. Julio has 2 cylindrical candles at different heights and diameters. The first candle lasts 6 hours while the second candle lasts 8 hours. He lit both candles at the same time, and 3 hours later, both candles were the same height. What was the ratio of their original heights? So it says the remaining height after 3 hours were the same, so we can draw an equal to sign first. So after 3 hours, the first candle still has 3 hours of its total 6 to go. So it still has 3/6 of its height left. The second candle is done with 3 hours out of 8. So if 3/8 of it are done, then it still has 5/8 of its height left. So let's call this height number 1 and this one's height number 2. And we want the ratio of their heights, which is height 1 divided by height 2, or height 1 is to height 2. Then you get 5/8 divided by 3/6. And if you simplify that, you get 3/5. And that is your answer. Or no, you get 5/4. There we go. That is your answer of C. Next we have problem 20. Aylin wants to create a path of matches using as few matches as possible. She places each match on the piece of paper like the one shown along one of the dotted lines. Her path returns to the left-hand end of her original match. The numbers shown in some of the cells are equal to the number of matches around that cell. How many matches are in this path? So if we draw the figure that is shown, we get something that looks like this. Then over here it says 2, 1, 2, 0, 3, 0, 3. And there's one match already placed over here. And it has to end somewhere on this side of that match. So first we need one more match over here. So let's just put it right here. Now this covers 2 over here, so this box is all good. And this box has 1, so it's done too. Now we need 2 boxes here, and we can't put another one there because this one only needs 1, so let's put it over there. Now we're done with this, and we can't put one here or else it'll get 3, so let's just keep going. Now this one has 3, and we can't use this side because it has a 0, so we have to use these 3 sides over here. And now we'll connect the path using as few matches as possible because we don't want to use as many matches. And it says on the question to use very little matches, as few as possible. We can't put any here because it says 0 matches over there, so let's just go over here and over here. Now we have to use these 3 sides for the same reason we used those 3. So we have 1, 2, 3 over there. Can't use any there, so we have to go here and here. Now we have met all the requirements and we used as few matches as possible. So if we count it, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So our answer is C, 16 matches. Problem number 21. The integers from 1 to n inclusive are equally spaced in order around a circle. The diameter through the position of the integer n also goes through the position of 23 as shown. What is the value of n? So you have your circle here. Number 7 and number 23 are here, and that's the diameter. So that means this side equals this side. So you have the numbers 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and 22. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 numbers. Therefore, this side must also have 15 numbers. This is part of the diameter, so it doesn't count. So then you have 6, 5, 4, 3, 2, 1, because it says it starts from 1. So 1, 2, 3, 4, 5, 6 numbers are used, and we need 15 numbers total. So that means 9 more numbers. So from here, if we have 9 more numbers, that's 23 plus 9, which is equal to 32. Therefore, our final number, which is n, is 32, and our answer is B. Problem number 22. Liam spent all his money buying 50 soda bottles at the store for $1 each. Hoping to make a profit, he raises the price and sells all 50 soda bottles at the new higher price. After selling 40 bottles, he has $10 more than he started with. He sells all the remaining bottles. How much money does Liam have now? So if he bought 50 bottles at $1 each, he started off with $50. So he started off with $50 there. Then he sold 40 bottles at the higher price. So you have 40 bottles at, let's just say X is the new higher price. Then he has 10 more dollars than he started with. He started off with 50, so 10 more than that is 60. Then you have X equals 1.5. Then he sells the remaining bottles, which is 10 more bottles left, so at the price of $1.50. Then you get 15 more dollars. So after selling 40 bottles, he now has $60. Now he makes 15 more dollars after selling the rest. So you have 60 plus 15 equals 75 bottles, and the answer is B. Problem number 23. Natasha has many sticks of length 1. The sticks are colored either blue, red, yellow, or green. She wants to make a 3x3 grid so that each 1x1 square inch on the grid, each 1x1 square inch the grid has 4 sides of different colors. What is the smallest number of green sticks that she could use? So if you draw the grid here, then you want to use as less green as possible. So if we put a green here, for example, then you see how it's getting used for 2 squares at the same time. So we're conserving the amount of greens we use. So we can put a green over there for these 2, a green over there for these 2, and let's put a green over there to cover these 2. And then, so let's just shade all the boxes that have green already, just so we can keep track. Now we need to put green over here, so we can put these 2. And then there's going to be 1 square where you just put a green off to itself. So everything gets covered. And we use 1, 2, 3, 4, 5 greens, which is the least that we can use. And there, our answer is C. Problem number 24. An ant would like to walk along a marked line on the surface of a cube until it returns to a starting point. From which one of the following nets could a cube be made so that such a journey is possible? So basically, we need to look at all of the figures and figure out which one all the lines connect up on. So if we look at A, and if you want, you could just like draw, get a piece of scratch paper and try to make a template and draw it on yourself. So if you do that, and you look at A, and if you try to connect all the lines, you'll realize it's not possible. So that isn't our answer. Like I said, just make a template, draw it out, and then try it if you can't, and then like draw it out and try folding it into a cube if you can't visualize it. But if you do, then you'll get A doesn't work. Then B, you'll notice that all its lines don't connect up either. Then if you try folding C's up into a cube, you'll notice those lines don't connect either, so therefore that doesn't work. Then if you look at D, and you try to make all the lines connect and form a cube, you'll notice that doesn't work either. Then if you look at E, then, well, first of all, that's the only one left, so it has to be E. And if you try to connect everything, it does work, so therefore E is our answer. Number 25. Elisabetta has a large bag of 60 chocolates. She started by eating 1/10 of them on Monday, then 1/9 of the remainder on Tuesday, then 1/8 of the rest on Wednesday, then 1/7 on Thursday, and so on until she eats half of the chocolates remaining from the previous day. How many chocolates does she have left? So you start off with 60, and you eat 1/10 of them, which means you have 9/10 left. Then that's 54. Then from 54, you eat 1/9, which means you have 8/9 left, and that is 48. Then from 48, if you eat 1/8, then you have 7/8 left, and that's 42. And then if you eat 1/7 of that, you have 6/7 left, and that's 36. And she keeps eating until she eats half of the chocolates remaining from the previous day. And then after she eats that, how many chocolates does she have left? So we've done times 6 by 7. Now if you notice the pattern, you'll do times 5 by 6, which is 30. Then 30 times 4 by 5, which is 24. Then 24 times 3 by 4, which would be eating 1/4, so you have 3/4 left. And then that is 18. And then again, we are now eating 1/2, which means she has 1/2 left. And after eating 1/2, she has 9 chocolates left. Wait, one sec. I skipped 2/3. You eat from 18, she eats 2/3 first. Then we have 12. Then she eats 1/2. And then she has 6 chocolates left. And then our answer is E. Problem number 26. Pratt painted each of the 8 circles in the diagram red, yellow, or blue, such that no two circles that are joined directly are painted the same color. Which 2 circles are necessarily painted the same color? So if you draw the figure here, it looks like this. Then you have 8 over here, and this goes back and connects with 2. So you have 1, 2, 3, 4, 5, 6, 7, 8. Now it says which 2 have to be painted the same color. Now they're either red, yellow, or blue. So let's say you choose any color here. Let's say, for example, red. Then these ones have to be yellow or blue. So one of these three have to repeat again. These two can't be the same. Since we have 3 lines here and only 2 colors, one of them have to share a color, which means 2 circles here have to have the same color, at least 2. So then you have 5 and 6 cannot share the same color because they are joined directly. So let's just say one is blue, then the other one has to be yellow. Now this one cannot be red or yellow, so it has to be blue again. Therefore, 5 and 8 have to share the same color. Then our answer is A. Problem number 27. When Rhea and Flora compared their savings, they found that the ratio of their savings was 5 to 3. Then Rhea bought a tablet and the ratio for $160, and the ratio of their savings changed to 3 to 5. How many dollars did Rhea have before buying the tablet? So you have 5 over 3. So this is Rhea is by Flora right now. Flora's never changes. So this is 5x over 3x, I guess. You can put 5 to 3, or you could leave it as an x, because here it's equal to, or Flora's stays the same. This changes to 3x to 5x. However, Flora never buys anything, so hers must stay the same. Therefore, if we have 3x equals 5x, we need a common denominator for that because Flora's cost never changes. So an LCM of 3 and 5 is 15. So if we have 5 over 3, that's also 25 over 15. Here we also have something over 15. 3 over 5 equals 9 over 15. And if she spent, these are still x's because we don't know exactly how much she had in the beginning. So it could be some multiple of this because it's all a ratio, which means they've just simplified and canceled out whatever the multiple x is here. So if you subtract 25 minus 9, you have that she spent $16 times something because we don't know how much like the multiple is. And it says she spent $160. And if you solve this, you get x equals 10. So now you can plug in 10 over here, or you could plug it into the original 5 by 3. No, you plug it in over here because this is your x here. So you have 25 times 10 because this is where you put x. So you plug it in to find Rhea's original cost. So 25 times 10 equals 250, and our answer is C. Problem number 28. Several 3-player teams enter a chess tournament. Each player in a team plays exactly once against every player from all the other teams. For organizational reasons, no more than 250 games can be played in total. At most, how many teams can enter the tournament? So we have X people playing against everyone other than themselves and the 2 other people on their teams. And since person A playing person B is the same game as person B playing person A, we'll divide by 2 to avoid double counting. So that equals, or it's less than equal to 250 because it says at most 250. So then we get x into x minus 3 is less than equal to 500. Now, it says here that in the answer choices that like the smallest choice in the answer choices is 7. So let's start with that. If there's 7 teams, that means there's 21 people. So we have 21 times 18. This is equal to 378, which is less than equal to 500. So it works. Now the next choice is 8 teams, which makes 24 players. So we have 24 times 21. This is equal to 504. So it's greater than equal to 500, which means we don't want it. Therefore, the maximum number of teams that can enter the tournament is 7, which is equal to E. Problem number 29. The diagram shows the square ABCD with P, Q, and R as the midpoints of sides DA, BC, and CD, respectively. What fraction of the square ABC is shaded? So you have your ABC here. CD. So this is what fraction of the square ABCD is shaded. And here's P, Q, and R. And then there's two lines over here and over here. And what's shaded is everything inside here. So now we have square ABCD, and the question asks what fraction of square ABCD is shaded. So we have the square ABCD out of ABCD, which is equal to 1, so it's itself. So we're just going to call this area 1. And then we have triangle DRA, and DR is half of DC, and DA is itself, so that'll be 1. And then you have triangle DRA is half times base times height, which is half times half, which is 1/4 times 1 is 1/4. Same logic for this triangle RCB, so this is also 1/4 of the entire square. Now the height here is 1/2 of AP, since we can make a rectangle over here, and this is the intersection of the diagonals. So 1/2 of AP, and AP is 1/2 of the entire thing. So we have this length is 1/4 of the entire length, and this is 1. So we have 1 times 1/4, which is 1/4, and we're multiplying that by 1/2 because it's the area of a triangle. So then we get that triangle AB, we'll call this X, is 1/8 of the entire square ABCD. Now you get 1, which is the area of the entire square, minus 1/4 plus 1/4 plus 1/8, and then we get that's equal to 3/8, and therefore our answer is E. Problem number 30. A train is made up of 18 cars. There are 700 passengers traveling on the train. In any block of 5 adjacent cars, there are 199 passengers in total. How many passengers are in the middle 2 cars of the train? So since there's 18 cars, let's label them all A through R. So you have A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, and R. This makes 18 cars. 14, 15, 16, 17, 18. And it asks for the middle 2 cars. That would be I and J if you counted it. And since this is the number of people in any 5 adjacent cars equals 199, we have A plus B plus C plus D plus E equals B plus C plus D plus E plus F, and they're both equal to 199. And using this, we find that A equals F. Using that same logic, we have B, C, D, E equals F, G, H, I, J, L, M, N, O, P. We have all this is equal to each other. A equals F equals K equals P, then so on as written here. Now you have that A plus B plus C plus dot 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 plus N plus O there's 3 sets of 5 in here, and every set of 5 has 199 people in it. So there's a total of 3 times 199 equals 597. So there's a total of 597 people in cars A through O. And now there's a total of 700 passengers. So 700 minus 597 equals 103, which is how many passengers must be in cars P, Q, and R. So we have P plus Q plus R equals 103. Now if you notice, P plus Q plus R equals F plus J plus H. And F plus J plus H plus I plus J equals 199 because there are 5 adjacent cars. And we want to know what I plus J is. So we have F plus G plus H also equals 103 since PQR equals FGH. Now you have F plus G plus H plus I plus J equals 199. F plus G plus H equals 103, so you have 103 plus I plus J equals 199. Then you have I plus J equals 96. So the total number of passengers in cars I and J is equal to 96, and our answer is D. Thank you for watching Math Kangaroo Year 2019, Level 7-8.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramathcircle.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email but without the info and the end. So bye!